Can you afford the hardware failure in AWS? Is your application, if it is not running, will your company lose money? Hello, I'm Sudhakar Moparte. Today we're going to talk about placement groups, how Amazon provides different options for you to take care of the hardware failure on which your application is running. So let's take a look at it. So this is the documentation that we are looking at. Placement groups. Placement groups, what are placement groups? And when to use, which one to use when? And how do you configure that in your AWS account? So I'm going to give you the c1c2 diagram for this, which will clarify you the concepts, and when you go and read this documentation, it will make you understand. All right, so this is our c1c2 diagram. We got a EC2 service, okay, so let's say, and then you can, there are different kinds of placement groups. So what is a placement group? A placement group is in which your instance is logically placed. Why is it important to group instances? Let me use my invisible pen. And I want to use a different color. Okay, so why do we want to group instances? Because if one instance fails for whatever reason, then you have an opportunity to run your application on a different instance. So let's say you put, you want 4 instances in this cluster placement group. So the reason why you want to do cluster placement is because you want those instances to be close to one another so that you can communicate back and forth between those instances. So you want to put them on logically clustered within a availability zone. Okay, so that is the concept. Whenever you need high network traffic, high throughput, and high speed communication between instances, then that's when you put those instances in a cluster placement group. Okay, so before going there for the other things, other placement groups, we'll talk a little bit about how this whole hardware is organized in AWS Cloud. So you got your instances launched. They are running on, these are virtual servers running on some sort of a host computer. There is one computer on which these instances are running. And this computer, host computer, is in a rack, in a particular rack, physically in a rack. So, and this rack is connected to this power source. So if you take these power sources, this power source is powering this rack. This power source is powering these 2 racks. And this host computer is in this rack. Suppose you want your instance to be on two different racks. So you have to make sure that you put that instance in these two different host computers. So one should be here and the other one should be here. Only then you can see you are separating the racks. When you separate the racks, the power source is also separated, right? So depending upon how badly you want your application to be running and will not affect your revenues, you will decide which placement group you want to use. These are the placement groups. So if you want rack spread, that means your instances should be on different racks, then you choose a rack spread placement group. If you want your instances to be on different hosts, then you choose host spread placement group. You want different hardware, different power source, and then you use these type of spread placement groups. You want the instances to be together, high bandwidth, fast communication, then you use cluster placement group. And you want different partitions. These partitions also utilize the similar thing. They won't share a power source. They don't share. You can put a maximum of 7 partitions, and then you can put in each partition your instances. And these partitions are basically will not share. This is the number of partitions. Each partition will not share any power source or rack, same power source and rack. Suppose I have this one, it's in one partition. This one will be in another partition. And then this one will be another partition. Like that. So different partitions you can make and then put those instances. So you get the idea. You want them to be together, you do this cluster placement. You want them to be spread out, by rack, by computer, by host computer, then you use spread placement group. You want them not to share any of the hardware and it's in the same availability zone, then you use partition placement group. Here, maximum number of instances in a rack spread placement group. Suppose if you are using rack spread placement group, then the maximum number of within an availability zone, the instances is 7. Okay. The reason they are limiting this to 7, if you logically think about it, they have to have a power source, and then that power source is supplying to 7 racks maybe. 7 racks. Maybe they only have 7 racks logically in the availability zone, and that's why they're restricting the number of instances within each rack. Suppose you want to, not each rack, within each availability zone. So if you have 3 availability zones, the maximum of 21 instances you can launch in that availability zone with rack spread placement group. If you try to launch an extra one, it will fail. Because you're saying, I want power source different, rack different. So they have some restrictions because of the way they set up that data center. All right, that's all for today. With this high level, hardware failures can be addressed by using placement groups. So with this knowledge, if you go and approach your design of your instance launches, your spread of instances and the applications running on those instances, why are we doing all this? Because we want our application to be available all the time. Suppose you take skill bank application, we are giving all this learning technology and reading the mind of a student and user while learning. And if this is not available, if that application is not available, it will be a problem for the student. Because of AWS hardware failure in a particular availability zone, and if I only have in one availability zone this application, then if something happens to that, to a part of the availability zone, then my application will be down and people will be affected. So I have to make sure that this application is spread across availability zones. This application is communicating using different hardwares, different power sources, and etc. So all this is possible as Skillbank user base and number of students joining increases. So it's a practical problem to be addressed. Right now, we don't have to address that much, but you have the capability to address when that need comes. And this is the way you solve those problems. Placement groups is the word placement. Where are you placing your instance? Okay. There are some rules in the documentation they specify. For example, if you down an instance, if you down an instance, if you terminate an instance and then you launch it again, then it is not going to be in the same placement group. So it may not launch because you said cluster placement group. So what you do is, suppose you want 4 instances, you launch all of them together. And then if one of them goes away, what they do is basically because they are sharing these computers and all that, the capacity may be there, may not be there in that same placement group or the where that previous instance was running. So if it is not available, then you get a capacity error. Capacity error. So to avoid, if you get that, then obviously you relaunch another placement group and terminate all the previous ones. And at once you launch. So it will find a machine that has that capacity and then put those instances there. So like that, there are rules. So you can have 500 placement groups max per region, like that. Okay, good luck and happy learning about placement groups in AWS. Take care. Bye-bye.